Hi, Scott. Thank you to be here with us today. I'm very happy that you found the time for this interview. And how are you today?
Oh, I'm great. Great. Thanks for having me.
Well, we will get started with the first questions. Can you just tell us a bit about you and your work history?
Sure. I'm an old guy, so I've got kind of a, a long work history, but I'll try to be brief while still covering the interesting bits. Let's see, I started my career with Borland International. They're here in California where I am. Well, actually, they're not here anymore, but they were based in Scotts Valley. And I spent a few years there, starting in 91. And that was very interesting for me. I learned a lot there. And then let's see, I was part of a program that Philippe Kahn started. A very interesting project. Myself and another guy were mostly the only people involved. And that was later sold to Paul Allen's company, Asymmetrics, in Washington. So we worked down here for a while, then we all just moved up there. And then 6 months later, they shut everything down. And so I moved back here and I started working at Netscape for a while. And that was a lot of fun. And then after that sort of wound down a bit, I left there and started a company with another colleague from Borland, and we started an analytics company, and that was pretty successful. We sold that, and part of that sale involved a contract, a 3-year contract, that ended sort of abruptly with a .com bust, and I took some time off because I'd been working a lot, and then I started with a brand new startup called Guidewire, where I'm at now, still many years later. Let's see, that was 2002, so that's 18 years. Most of my time at Guidewire was working on a language called Gosu, which is a JVM language, general purpose, OOP, a lot like Kotlin, but predates Kotlin, if you're familiar with that one.
Yeah.
And what we're going to talk about later is Manifold, and that's something I'm doing on my own. And a lot of the lessons learned from Gosu are now applied to Manifold, which is a whole separate, we'll talk about that later, but it's a separate sort of project that concentrates purely on Java.
Yeah, it's a very interesting topic, and I think it was the main excuse that we found for this interview. So I think we will dive into this.
Okay.
And okay, you name a lot of very interesting company, but for someone that is working in this field, so building tools for, especially for developers, I'm very interested in your experience at Borland. Can you tell us a bit more how it was to work there?
Well, at my time at Borland, particularly in the beginning, I was just a young guy right out of college, and I worked on Object Vision, which was Borland's first product on Windows. And back then, that was Windows 3.1, I believe. And that project was acquired. It didn't start at Borland. It was acquired from another company in Texas, a very small startup. Just a group of guys. Those are the guys that I got to know really, really well, and learned a lot from them in the beginning. And you know, one of those guys was a colleague that I had started that company with that I mentioned earlier. And yeah, I think I've learned more there than probably anywhere else at any given time, which is a lot, because I've learned a lot over these past years. And I wouldn't say the lessons I learned there were not just purely, technical. It was, how to be a developer and, how to get along and that sort of stuff. And they were great mentors, those guys.
Yeah, no, it's fascinating. Like certain companies seems to be more influential, and maybe for Borland
Yeah.
was.
Borland was, it was a great place to be. It was very exciting at that time because they were sort of at the peak of language development. They were also experimenting with, desktop applications. They had a word processor. Of course, they had, Quattro Pro. A lot older people might remember that as a spreadsheet. It was very, very, very well produced product. And Microsoft wanted to destroy them, probably more than any other company at the time. And I don't want to spend too much time on this, but I think Borland, there probably is as much to blame as Microsoft, I think, for their demise back then, from some of the decisions they made. This is my own opinion, but they made some mistakes along the way, like spending, I think, this more than a year developing IBM OS2 versions of their products, and that sort of set everybody back because we didn't have separate teams for the OS2 system. So we had one team working on that. So that sort of set us back. We lost a year at least in terms of our competition with Microsoft. And so I don't think that helped much, but there are other things. But it was an exciting time, probably the most exciting I've had since. I sort of peaked early in that sense. I could never compete with that again.
Well, I think you have built some very exciting things, and I think it would be nice to speak about the first one, Gozu, that I know that is it's not your main focus right now. We will speak more about your main focus, Manifold. But I think Gozu is interesting because as far as I know, was one of the first JVM language that come up, and now we are starting to see a few, like you named Kotlin before, or Scala, Groovy, and so on. But Gozo, as far as I know, was one of the first ones, and it also has some interesting ideas. So can you maybe tell us a bit about Gozo?
Sure. When I started at Guidewire, I had no intention of building a general purpose programming language or any language, really. I was hired to work on their architecture that they were just beginning to build. Just as a background, they build property and casualty insurance software for mostly medium to large insurance companies. But right now I can't even keep track of our customers anymore, but we've got a lot of big ones. So we started out with just a few guys, and now we have thousands of people and many, many customers. Anyway, I was hired to work on architecture, and one of my first tasks there was to research building a rules engine and language and tools, because we did know we needed some type of business logic that we needed to present to what we called knowledge workers at the time.
Mm-hmm. Oh, that's a good term.
Yeah. So not necessarily programmers, but programmers. It's marketing always has this dream of somehow connecting the dots between non-programmers, and it just never works. But we just sort of accept it and say, okay, yeah. But I didn't have a whole lot of luck with finding tools that could satisfy our needs. There were a few rules engines and languages. A lot of them tended toward the natural language side of the spectrum. What we really wanted was something like a good solid scripting language, but that was also statically typed, because we also needed stuff like code completion and stuff where you really want to have static analysis, at least static analysis that's approachable. And there really wasn't a language like that. Just a imperative, nice little language. So I said, well, okay, we can build this. I've built languages in the past, nothing big, but we can do this, a nice sort of expression language with some constructs to, get us what we need and that sort of thing. Well, we did that. We built the rules engine, and it was very, very successful. And then that led to, well, maybe we can use this over here, and maybe we can use that over there. Okay, well, and one thing led to another, and one day you wake up and you have a general purpose language. That's sort of how it developed. It didn't take long, maybe probably over the course of 3 years, I think, by the time we had object orientation and all of the ingredients, you'd expect. And then over time, it just kept on, fleshing out more and more. It's accidental language.
Yeah, because I guess that if you went to the managers the first day and you asked them if you could build a general purpose language to be used all over the company, probably they would have said no.
Yeah, resounding no. In fact, I think we talked about this a while ago, but our company has gone through many phases of why are we doing this? Why do we have this language? And the history isn't there, so a lot of newer executives come in and they look at this and go, why we're an insurance software company. Why are we developing it? And I've had to give many presentations on the why part, and I've had to convince, a lot of people over and over, sometimes the same people over and over, why we're doing this. And right now we're in another one of those phases where I think we're emerging from one of those phases where they're realizing, okay, we do need it. Now we want to spend more time and resources on it again.
Maybe companies, when they're smaller, they are more tolerant to making choices that are not common because they need a competitive advantage, while when they're established.
Absolutely. The company now that we call Guidewire is vastly different from the one, the first 5 years of our existence. That's true for any successful company. They're going to go through changes and they're not going to be the same. So like you said, the kinds of decisions we had to make earlier on were sometimes desperate ones. We have to do this and we're under time constraints. We only have 1 or 2 customers and we have to meet their needs. And so features stem from a more hostile environment than they do now, where we get to call the shots, not so much the customers. When you become so successful that you kind of own the market, you can sort of dictate what their needs will be. You sort of set that pace, and that's sort of where the company is now. And it explains our most recent lapse into this phase of why are we doing this again? And so, yeah.
Makes sense. And was it difficult to build a language on the JVM? I mean, I guess that the JVM was built originally having just one language in mind, Java, right? So I don't know if it constraining?
It really wasn't. I don't think the JVM was really ever sort of a roadblock where, we really need this feature that isn't there. There are definitely times where I've wanted features that weren't there because I wanted some other feature in Gosu and I had to sort of work around it. But the JVM's never really been a problem. In fact, earlier on, Gosu wasn't compiled. Well, that's not really altogether true. It was compiled into an intermediate form where we sort of had this odd AST that had execution sort of bolted onto it. So we could execute the AST at runtime, if you can wrap your head around that, which had a lot of advantages, actually. It was nice, but it was slow. And, there came a time where, it really caught up to us. The profiler was flashing red, all over the place. And so we had to make some changes. And of course, you have to compile at some point when there's enough use of your language. So transforming the the old compiler to the new one where we're generating bytecode, that wasn't that much of a big deal either. It was a learning lesson for me because I really didn't know that much about bytecode at the time. I wasn't an expert at it, so I had to learn it, along the way. But that was an interesting process, learning all that, and learning the oddities of bytecode and like the JVM, like why does try catch finally work this way, and why didn't they? All these sort of questions and expectations that you have. But I never really felt like the JVM or the Java language was in the way, so to speak. It's always been a pleasure to work with, really, and that extends to our next topic as well. Like I'm surprised because it's so old, and I would expect it to be, difficult, but it never really was.
Talking about the challenges of building a language, and this is also a topic that leads the way to Manifold. Can you tell us a bit about the tool support and how, if it was difficult, how much effort did it take compared to build the rest of the language?
So if I understand your question, like just tooling in general, like with Gosu, like
Yes, the idea, especially, I mean, building support.
sure. Originally, we had our own IDE that I also built with my team. Because I'd done a lot of that in the past as well, ever since Borland, really, and even before Borland in school, doing that. That was my interest, and that lasted only so long. We had a debugger, and it was very capable, but at some point it breaks down where, especially with source control and other integrations that you need in an IDE for, real solid professional heads down work. And as demand increased, for the language to be applied in different places in our technology stack, we just couldn't do that anymore. So we were targeting Eclipse in the beginning, and then that just became a nightmare. Eclipse was never really designed for language independence. Mm-hmm. It's meant for Java. So there's a lot of ways you can sort of change its behavior to fit your language, weaving and all these things. You end up having this huge mess, or you basically take your own branch of Eclipse and build your own. But that sort of defeats the purpose, because now you're off the reservation. You can't necessarily use the same plugins and these other things that you're there for in the first place. Yeah. And I'd also earlier on had built debugger support in IntelliJ for Gosu as a separate sort of project with some minimal editing. It was sort of a lightweight plugin. But in doing that, I realized, wow, JetBrains did this right. This API is exactly what I need, and I want this now. And I managed to convince the IDE team at Guidewire that we ought to be, let's drop this Eclipse stuff and let's jump over to JetBrains. Internally, we were using IntelliJ anyway, so most of the developers understood at least the benefits of the IDE. They weren't sort of so attached to Eclipse. They weren't so biased maybe to it. So that helped. So we went that route. And then we had several iterations of our Gosu plugin as well. The first one, it basically piggybacked on the Gosu parser because we didn't really want to write another one. Right. And there was a lot of advantages in that, but there were also disadvantages. And a lot of the disadvantages started to really, get in the way. So we switched over to building a real parser, in IntelliJ terms. And our time constraints were our enemy there. We ended up making a lot of shortcuts and reusing a lot of Java code from JetBrains to make stuff work. And it turned out a lot better than I expected. The team that was working on that, they were awesome. They got a lot done in a short amount of time, but it showed after a while. Like, so we had yet another iteration to fix up a lot of that stuff, and so now it's in much better shape, much better shape. So that's where it's at now. So it took a while. I'd say where we're at now, I'm just going to guess, say 8 years maybe before we finally settled on something that, we feel good about. It's always that way though with these things. You've got product cycles, and if you're going to sell products and make money, you have to decide of which of these things am I going to do and which things am I not going to do, because I can't get them all. It's classic.
But I think your experience with IDEA, the platform from JetBrains, came very useful when you started working on Manifold.
Oh, absolutely. So Manifold, that grew out of one of these stagnant periods of GoSu within my company, the most recent one. And I had a lot of ideas brewing in my head. There's a lot of stuff I could do with Java that I think would be really useful, just for my own purposes. But if it's good for me, it's got to be good for everybody else. And a lot of the ideas came from GoSu. Where else am I going to draw from? So I don't know how, what subjects you might want to cover there. But yeah, definitely my experience with IntelliJ plugins, with GoSu definitely helped a lot. Otherwise, I don't think I would have had a lot of these ideas. So it's one thing to think about the language. Oh, this would be a great feature. I can maybe weave that in through a Java compiler plugin, blah, blah, blah. But then you've got this other mountain, you've got to climb, that's the IDE. Because at least in my mind, language features are nothing if they don't have IDE support.
Yeah, I totally agree with that.
There are a lot of guys, I was one of these. Before I started at Guidewire, I used the IDE for debugging. And I felt like I don't need all that stuff popping up. I don't need all that. I use my head. I can remember, where all these things are and what the names are and what methods run what. I can do refactoring and use grep and blah, 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 blah. Like all the same excuses. But, luckily, like one of the guys in particular at Guidewire, really great guy. He was patient with me. And he convinced me, okay, you just got to give this a try. Just do it. I'm like, all right, I'll spend a week in it. I'll just immerse myself in this, and I'll throw my, my code editor away, which I still like, but just throw all that stuff away. And I never came back. I think it took maybe a day, and I'm like, oh, geez. Yeah, well, I'm glad, his name was John. I'm glad, John, that you sat me down and made me do this, because this was great. And I never looked back. I can't fathom programming professionally, with a statically typed language without having an IDE. I'm going to say like IntelliJ, but there just isn't another one like it. And I've used them all. I've used Eclipse for long periods of time, and it's great and all that, but like IntelliJ is like up here.
Yeah,
I don't know how much longer it'll stay up there, but those guys are they know what they're doing.
I had a similar experience because at some point I was an Eclipse guy because I was writing plugins for Eclipse using the Eclipse modeling framework, and I was very happy until a colleague of mine at TripAdvisor suggested me to take a look at IntelliJ, and I was a bit resistant, but then I tried and say, okay, what I was doing.
Yeah, it really is. I can't believe they've kept the pace. Their innovation for how long? Like this has been 2002, like 18 years for me, and they keep getting better and better. Like some things I wish they would just leave alone, but they keep getting better. It's amazing.
Okay, but now let's dive into Manifold, and it's something new, so I think it's difficult to explain to someone that has not seen it before. So we will include maybe some video in the article connected to this interview. Can you give us an overview of what Manifold is, what it enables you to do?
Sure. Manifold does a lot of things, and that's maybe one of its weaknesses is that it does too much. But at a high level, what it does is it redefines this notion of a code generator, and a lot of the language community will call the subject type bridging, where you've got your language and your type system, and then you've got some structured data over here, and you need to access that structured data. And how do you do that? And for decades, the answer has been write a code generator or write some library where you lose, type safety. And I don't know about you, but I've worked on a lot of code bases that involve a lot of code generation, including the one I'm on right now at Guidewire. And I can't talk too much about what we have internally, but there's a lot of code that's generated, and it adds up. And dealing with it becomes, I think, a liability over time. There are a lot of issues that you have to solve, or problems you have to solve, that just don't go away. And over time, you just accept it for what it is, because you don't really think there's another way out. And it's just something you just accept. So it's like riding a horse to work. If that's all you know exists, it sucks, but that's what you do. But had you known there was a car and roads, maybe you would do that instead. So I'm not saying Manifold is that much of a difference, but I think it's a compelling difference. And what it does is changes all of that by teaching the compiler how to deal directly with this structured data. And when I say structured data, I mean almost any kind of information. And I often refer to it as a resource. And Java programmers know what resources are. Like you might have XML resources or JSON resources, even JavaScript. You might have other languages, GraphQL, SQL, whatever.
So maybe let me try to see if I understood. Let's suppose that you have an XML file that is maybe written according to some XML schema. So normally you could use in Java the API to get a node of a certain kind, and then you know that this node has always this couple of attributes, but the XML library doesn't know that, so it will not suggest, for example, that when you have a node of this type, you can have the attribute, I don't know, name and address. And so you can try to use it, but you are not sure it will return the results. If you misspell the attribute name, you get an error. So you could instead generate Java classes for each kind of XML node for which you have the structure. But this is cumbersome. If the schema change, you have to regenerate the code, or you could use Manifold, and this would solve these kind of problems.
Yeah, that's pretty much it. You could either use a code generator for XML, and there's many of those have been around for a while, right? But the problem with that is there's this disconnect, and that's why it is called type bridging, right? We've got a bridge Java's type system, which is over here, with this XML stuff, which is over there. And that's where all the bugs are, is in between, right? All of the code generators, and writing them and managing. When do I run the code generator? How do I hook this up in the build? Now in my IDE, I can't. There's this disconnect. I want to, like, where does this method come from on here? Like, Where is this type from? What is this thing? How do I change it? All that stuff is out the window, right? And let's say you could change it. You do know where to go to change it. Okay, I have to change this schema file, or maybe it's just a plain XML file. I go make the change. Now what do I do? Okay, I have to recompile everything. Or some smart guy wrote, some integrations with whatever ID you're using and all this stuff, and that happens to all work. Well, that's like a one-off thing that can break. If that guy gets hit by a bus, he's probably the only guy that knows how to fix it. There are all these problems that really pile up, and I've just scratched the surface. You've got caching issues, all sorts of stuff. And what Manifold does is it says, okay, all right. So the main problem here is the compiler doesn't know what that XML type is. Let's solve that problem by sort of inverting it. Let's make the compiler ask for the type and have a way to plug into the compiler to satisfy that that type resolution. And that's really what it is. Manifold provides this connection for you. So Manifold is a plugin that offers an SPI, which is an service plugin interface, an API for other people to plug in. So if you want to write an XML or an XSD manifold, you can do that. Now all XSD files, all XML files, they suddenly all are alive in your IDE, and there's nothing more you have to do. All the changes you make are automatically recognized. And this is another issue. There's an IntelliJ plugin and an Android Studio plugin where any type manifold you write that plugs into Manifold automatically works in IntelliJ. So all the navigation, I want to do Control B here, and automatically connects to the element or the attribute in the XML file over there, or what have you in GraphQL or JSON or whatever it is. It all just works, and that's how the code is generated. The API also includes annotations that you can include in your code that make all that work in a standard way. So just by saying, okay, maybe we can open up the compiler so that the type system is more open and agreeable to this stuff. And all of a sudden, all these problems, they just melt away. But it's very, very hard to get this across. I've been waving my hands and flapping my lips to you for several minutes now, and maybe you still don't understand it, right? So using it, maybe you do. I think you do by now.
We have spoken before. We saw the video, but it's true that it's maybe a problem that at some level developers feel, but probably something that they say, it's just how my work is. So I do not expect there to be a solution.
Yeah. Absolutely. Yeah. And I can't blame them. I can't say I would feel any differently either, right? Like, I'm comfortable what I'm doing here. I'm dealing with this, maybe it is a mess, but it's my mess and I know how to work with it. And I don't want to change anything because I don't want to disrupt stuff. That's fine. I can't say that I would do anything different. But just having people understand, most people just don't, that I encounter that, want to know, or they email me, or they'll contact the Slack channel for Manifold. And it's difficult to get that, like this face-to-face we're having. There's more to face-to-face communication than meets the eye. I can have an easier time explaining this with you than over like a Slack channel or email or something. I'll just give it some more time. And in fact, I'll just say, like today on Hacker News, like there's a front page link to Manifold that was last thing.
I saw it last night. Well, it was night for me when I had. I think it just started at 5 points. I saw the title. I click on it. So,
all right. And
then I saw it was rising up.
Yeah. That was interesting, but still, like the commenters on Hacker News, or they are what they are. But it's kind of frustrating sometimes. Like, okay, yeah, I'm doing my best.
I think it's very difficult to promote these ideas even when they have a lot of merits, because these are not things that people Google for, right?
Right, right,
Because they couldn't express this problem they feel they have. You were saying that Manifold does a lot of things, and so to explain Manifold to me, you were explaining it in a certain way at a meta level. So you were explaining the class of problems it solves. So while maybe it's easier for someone to understand a single problem, like, oh, I have this problem with the database.
right. Absolutely. Yeah. That's the approach, really. Like I said, it does too many things at once. If you go to the Manifold page, I try to give a nice high level, like, perspective on what its capabilities are. But even that, I look at it and I go, this is too much. Yeah. 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 Like, for instance, we just talked about the generals, what a type manifold is, as opposed to a conventional code generator. Well, another aspect of the type manifold is, well, okay, I can own types in the compiler. I can claim ownership of these things. That means I can own existing types, not just new ones that I want to say, and create from an XML file. So what we get out of that is this notion of extensions. So other languages like C#, Scala, Kotlin, a lot of the newcomers, they have like extension methods. You can add your own method logically anyway to another type. Well, Manifold does that now using the same general principle here where, okay, I'm going to feed the compiler this code. It's basically a projection of code that the compiler believes is the type's code here, and then you just sort of faking out the compiler that it thinks that method is on the class, but it never really gets there in terms of bytecode on disk. It's just a facade. And then we, internally Manifold rewrites the bytecode to make it call this other thing that you invented. But that's there too, and as well as a lot of other things. So a lot of things just have nothing to do too with the whole code generation type manifold stuff. There's other features that I thought would just be nice to have while I'm in there mucking around in Java C code. I might as well add, a precompiler and string. I call them string templates, but there's a fancier name for it, string interpolation. And there's a list of stuff, and it's too much for any one person to compile all at once.
Yeah, maybe once you get the features, you are glad you have them. Maybe at the beginning it's overwhelming. There are so many things. Maybe it's a little bit like explaining an IDE. If you didn't know what an IDE is, you will say, oh, this is a things where you can see a list of the methods of your class, and there you can connect to a repository, and there you can find the usages. And it's until you tried, do not see the holistic view and how all the bits fit together and how they improve the way you develop.
Yeah, I think you're right. I think you can't, point the fire hose at somebody and just unleash the, 20,000 gallons on them all at once. You got to give them a drink of water. Yeah, I think that's absolutely the problem. I'll find a way.
So you will say that now your challenges are more on explaining the idea behind Manifold than technical challenges?
Well, there's always some technical challenge. There's always something else on my horizon that I'm about to tackle. I may need to learn about. But the primary issue with Manifold as far as adoption, getting traction, is explaining it. It's not self-explanatory. I'm not the best writer in the world. I try to do my best on the website, and each part of Manifold is broken down into a separate dependency you can use in your Maven or Gradle build. So it's all modular, and each module has a README, standard README file in GitHub where you can go check out what's going on in there with examples and so forth. But it's still just, I think, too much. There needs to be some other sort of entry-level kind of way for someone to settle into this thing.
Now that the simplest way to take a first look at Manifold is to install the IntelliJ IDEA plugin, or is there another approach that is easier?
Yeah. You can use Manifold without the IntelliJ or Android plugin, but it's designed, to be used in those environments. The static typing and it wants to be used in an environment like that. But you've got so much more potential. The development experience is orders of magnitude better in those environments. So yeah, I would say absolutely install the plugin in your IDE, and you can tinker with it. So you don't have to install everything at once. You can go to the Manifold website, and you can read the high-level bits about the features, and each bit will tell you, here's how you can use this. Here's how you can incorporate this into your build. You can have existing projects. Manifold doesn't make you do anything strange, like, okay, well, now your whole system has to work a different way, or you got to use these weird class loaders. It doesn't do any of that stuff. You just put this stuff in your Gradle or Maven dependency list and add a compiler argument. That's basically it. It's a little more involved, but not much. It's on the website, and it's sort of self-explanatory. But I think getting people to that place where they want to experiment with it that's the trouble. At least with the type manifold aspect. Other aspects like the preprocessor or string templates, string interpolation, like turning off checked exceptions, that's in there too. Like people that are using newer languages like Kotlin and Scala, like they understand and the benefits in doing that. It's kind of a controversial topic, but it's there for you if you want it. There's other stuff in there that don't need much explaining, but okay, now you can use XML this way. People are like, they're kind of hesitant to jump into something like that. I think GraphQL has been probably the most successful of the different type manifolds that are there because it's newer. There's not a whole lot of legacy stuff that you have to be nervous about changing. And I've gotten a lot of good feedback on it. And so I think that's helped, like GraphQL being relatively new and people more willing to experiment with something like this. That's helped a lot.
Yeah, and I guess when people have worked in a certain ways for 30 years, it's difficult to convince them to change. I think the preprocessor could be useful for a problem I was facing the other day. Basically, I have a piece of software that I can sell with a license, or I could use in other projects without a license. And of course, I would like to have a way to disable that license enforcing code, right?
Yeah. That's another issue with Manifold is there has to be some way for me to support this development, right? Free software is great, but it can only last so long, right? So what I do with Manifold is I give it away. Go to GitHub, download it all day long. It's free. It's Apache 2. Same thing with the IntelliJ plugin. They're free stuff. So if JetBrains has a free product like Community Edition IntelliJ, it's free for that as well. But the line in the sand is when you cross over into, say, like IntelliJ Ultimate. That's their commercial product. So if you're there, well, then you also pay for the Manifold plugin.
After all, you are selling like an extension to a paid product. So the extension to the paid product is commercial. The extension to the free product is free.
Yeah, and that's, I think, worked out pretty well. Some people were pretty upset about that in the beginning when it started. And I said, well, if you can use Community Edition, and it just didn't work so well for some people. And I was like, well.
Sometimes I think people feel entitled to receive things for free. No, I think every open source maintainer have experienced that. Everyone who has a blog have experienced that.
Yeah, I don't understand that mentality myself. I could see, okay, I'm using software. I've been using somebody else's software that's been free for a while, and now all of a sudden they change over to paid. It's commercial. Like, okay, now I've got to pay for this. Well, just consider yourself lucky for having not to have paid for it in the past, right? Like, if it's not worth paying for, then don't use it, right?
On my blog, there are a few hundred articles, and on some of these articles, maybe when you reach half of the article, there could be a box where you can subscribe to the newsletter, or maybe sometimes there is a pop-up that comes up after you have read it for a while. And I had person writing me insults because I dare to put on my own website some advertising. And it's crazy. Like, people just expect that whatever you do, it comes for free. And
yeah. I don't know. I've had people do similar stuff, but not on my own site, but like on other sites, they'll go and badmouth it and say, don't use this. This guy charges for it now. And all that stuff. Like, sorry, man. I feel bad. I can't help but feel bad. Like, oh, I've disappointed this guy. But at the same time, like,
I'm sure the guy works for free.
Probably does. Yeah.
Okay, so sorry for the for deviating.
Okay.
You have a website that I think is manifold.systems. Is that correct?
That's right.
We will put the link so people can go there and learn more. They can install the free plugin for the community edition, and they like it and they want to use for the JetBrains IDEA Ultimate or equivalent versions. They can buy it. That should help people that are interested in this, exploring this more. I think we are running out of time. I took over 1 hour of your time already.
It's okay. That's okay, as long as you want. But yeah, that's probably too much of me, though.
No, I think it's been very interesting, and you have done a lot of stuff and had a lot of interesting experience. So I think it was interested to dive on this. But before we wrap up, I wanted to ask you if there is anything that I didn't ask, we didn't discuss, that you wanted to add.
I think we covered a lot. I don't think there's anything really that we missed. Maybe later I might think, we would have, but I don't think so. I think we covered plenty here.
Yeah. And in any case, we can have a second one.
Okay, anytime.
Yeah. Okay, so we have already discussed about where people can find more about Manifold, so at manifold.systems. And is there any other resource that people should use?
No, again, there's the GitHub for Manifold also, but there are links to that from manifold.systems. And just Google, you can just Google like Manifold Java, like those two words, and you'll see a page of Manifold stuff. So there's always that. And that's probably all they need to, anyone would need. to begin looking at it.
Perfect. Then, well, at this point, I will thank you a lot for spending this time for us, for writing Manifold, and for telling us about it. So thank you.
Thank you for having me. It was great talking with you.
Thank you.